Now next question we are taking is a ball is allowed to fall from the top of a tower or a building, you can say, which is 200-meter high, and at the same instance another ball is thrown vertically upward with an initial speed of 40 meter per second, and we have to calculate after how much time and at what height the two balls will collide. Now you know one ball is going upward, so its motion is retarded motion, and the second ball is coming downward, so the motion is accelerated motion. Now total height of the tower is 200 meter. अब say, because in this case say the two balls strike after time t and height is x from the ground. So in that case, if the ball A we are taking which is coming in the downward direction, so for that ball initial velocity is u. So height covered or distance covered will be 200 minus x, and for ball B the initial speed is 40 meter per second. Time distance covered is x and time taken is again t, means in same time one ball will cover the distance x and the other one will calculate cover, or you can say 200 minus x. So for the ball coming downward, if we apply the equation of motion, s is ut plus half gt square and u in this case is 0, so we get 200 minus x is half gt square. And for the ball B which is thrown vertically up, we will have x is ut minus half gt square. So we get x is 40t minus half gt square. So if we add the two values, so on the left hand side we will have 200 and on the right hand side half gt square will get cancelled. So we are having 40t. So on solving we get t is 5 seconds. Now if we substitute the value of t in equation number 2, so we get x is 200 minus 125, that is 75 meter. And in these numericals, everywhere we are taking the value of g is 10. So whether it is given in the question or not, you can take g as 10. And now the last question we are taking, a moving body covers a distance of 20 meter in the 5th second and 32 meter in 8th second. And we have to calculate the initial velocity and acceleration of the body. Now you know in total time if it is t, then distance covered is given by s is ut plus half at square. And we have derived the formula that distance covered in particular second is u plus half a 2t minus 1. Where t is the time for that particular second, a is acceleration, u is initial velocity. So we will have two cases. Now case 1 is saying distance covered in 5th second is 20. So we will have 20 is u plus half a, 2 into 5 minus 1, means in place of t we will put 5. So we get 20 is u plus 9a upon 2. Similarly for case 2, for 8 second distance is 32. So we get second equation as 32 is u plus half a, 8 into 2 minus 1. Or we can say 32 is u plus 15a by 2. So if we take equation 2 minus 1, then we will get 12 is equals to 6a upon 2. Or we can say 12 is equals to 3a, or a is 4 meter per second square. And if we substitute the value of a in either of the two equations, we will get, like say for example we are substituting in 1. So 20 is u plus 9 upon 2 into a, so 9 upon 2 into 4. We get after solving q is 2 meter per second. That's all for the day.